All right, geometry students, welcome to section 3.3, which is proving lines parallel. Okay, so we're going to be proving lines are parallel today. In addition to your note sheet, you should also have handy your formulas and theorems for chapter 3. So today for your bell work, you guys needed to write down pictures for your corresponding angles postulate, your alternate interior angles theorem, the exterior angles theorem, and the same side interior angles theorem. We are going to review those real quick before we get started. So the corresponding angles postulate, the one for alternate interior angles and exterior angles and same side interior angles, all start with the same words. Every single one says, if two parallel lines are cut by a transversal, then something happens. If two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal, if two parallel lines are cut by a transversal. So you have the same hypothesis for each of those. Now, of course, for the corresponding angles postulate, you are going to have a pair of corresponding angles. Now, when they say that two parallel lines are cut by a transversal, think about how you show somebody that two lines are parallel. So you have noticed these in your pictures, I hope. They are going to be two little arrows. So if you are given that they are parallel, you know corresponding angles are congruent. So a pair of corresponding angles, I could call this 1 and 2. So because these two lines are parallel, we know that 1 is congruent to 2. Let's go ahead and give these lines some names. So this will be L, this will be M. So because L is parallel to M, we know that angle 1 is congruent to angle 2 by the corresponding angles postulate. Now it's also important that we have that they are congruent, because sometimes they are congruent, other times they could be supplementary. But for corresponding angles, they are going to be congruent. For alternate interior angles, they're going to be congruent. And for alternate exterior angles, they are going to be congruent. Okay, so I want you to think about how you're going to enhance the pictures that you drew for bell work today. And so for the alternate interior angles theorem, again, we have two parallel lines, so let's mark those. You can mark yours if you haven't already. And then we just have to put these in the correct place. So for alternate interior, I could put 3 and 4 here. I can call my lines P and Q. So it's because P is parallel to Q that leads me to say angle 3 is congruent to angle 4. So because of the parallel lines, my alternate interior angles are congruent. And then I have alternate exterior angles. So I'll call these 5 and 6. How about K and J? So because K is parallel to J, oops, I didn't put my parallel symbol on there. So I'll put that back on. Because those are parallel, we know that angle 5 is congruent to angle 6 by this theorem. Now the same side interior angles, it starts the same, but for same side interior, they are supplementary, which means when you add them together, they are going to equal 180 degrees. So that's going to look a little bit different when we're writing out our reasons, but we are still going to start with my two parallel lines, and they are cut by a transversal. So same side interior, I can do 7 and 8 here, and we will call these A and B. So because A is parallel to B, we know that the measure of angle 7 plus the measure of angle 8 is going to equal 180 degrees. Okay, so make sure that you have updated your bell work, so enhanced your bell work there. So you have your parallel lines written, and then you have this part written. because they're parallel, these are congruent. Parallel, congruent, parallel, congruent, parallel, supplementary. Okay, so now that we've reviewed that, we are ready to talk about proving lines parallel. So when you prove lines parallel, a lot of times what you're going to do is use the converse. So the first thing we're going to talk about today is, what is the converse? So here's our reminder. The converse is, if P is congruent to Q, then Q, or not congruent, sorry, if P then Q, this would be then Q then P. Okay, so we have P and Q, converse, you are going to switch them up. All right, and then our first postulate is the converse of the corresponding angles postulate. Okay, so for the converse, let's also just write down that the hypothesis and conclusion switch. So this is why we went over our theorems. We highlighted the hypothesis in all of these, okay? And then we highlighted parts of the conclusion. So if I'm going to switch these around, instead of saying if two parallel lines are cut by a transversal, that's now going to be my conclusion. This is going to be my hypothesis. So let's look at this. This says if two coplanar lines are cut by a transversal so that a pair of corresponding angles are congruent, then the two lines are parallel. So remember, we started talking about parallel. Now it's what we're going to end with. We'll put this in a nice little cloud here, a parallel cloud. All right, so the difference is what you would be given is that two angles are congruent. You would have to look at your picture and say, oh, 1 and 2 are corresponding. So because these are corresponding, it would follow that these two lines are congruent. So if you're given 1 and 2 are congruent, your conclusion is going to be that M is parallel to N by the converse of the corresponding angles postulate. Okay, so again, I want you to understand the big thing that makes these two different is here you're given parallel, you end up with the congruence. Here you're given the congruence, you're ending up with the lines are parallel. Okay, so you're proving that your two lines are parallel to each other. So if we look at our first example, it tells us that we're using the converse of the corresponding angles postulate to show that these two lines are parallel. So that's what we want to do, is show that they are parallel. So make sure whatever I'm writing down, you're writing down as well. I know some of you are thinking, I don't want to write all this down, but I promise this will help you get into the correct mindset for when we start to write out those two-column proofs. So when they say 4 and 8 are congruent, the first thing you want to do is look at your picture. So if I look at my picture and I identify where 4 and 8 are in my picture, I have to decide what type of angles these are. So our angles are either corresponding, alternate interior, alternate exterior, or same side interior. So 4 and 8 are, if you guess corresponding, you are correct. So 4 and 8 are corresponding angles. Okay, so then we would say, therefore, L is parallel, so remember that's our symbol for parallel, to M by the converse of the corresponding angles postulate. Okay, and that's all we have to do for that. Okay, so because 4 and 8 are corresponding, L is parallel to M by the converse of the corresponding angles postulate. Okay, for B, it's a little bit different. So for B, you're given that the measure of angle 3 is 4x minus 80, and the measure of angle 7 is 3x minus 50, and you are given that x is equal to 30. Okay, so again, let's go ahead and find where 3 and 7 are. So those I marked with 1 line, these I'll mark with 2. Okay, so 3 and 7 are corresponding angles, so they should be equal. So what we're going to do is make sure that they are using what we're given. So the measure of angle 3 is equal to 4x minus 80. If x equals 30, we are going to use substitution to plug in 30. So 4 times 30 minus 80. So 4 times 3 is 12, which makes that 120. So 120 minus 80 is going to be 40 degrees. All right, now let's go ahead and see what the measure of angle 7 is. Remember, in order for us to use the postulate, they need to be the same. So I have 3x minus 50, so I'm going to substitute in 30. So 3 times 30 minus 50. 3 times 30, 3 times 3 is 9, so this would be 90 minus 50, which again is going to be 40. Okay, great. So because the measure of angle 3 is equal to the measure of angle 7, and those are corresponding angles, or you could say the measure of angle 3 is equal to the measure of angle 7, or angle 3 is congruent to angle 7, we know that L is parallel to M by the converse, so again you have to say the converse of the corresponding angles postulate. Okay, so if you're given a value, you have to plug it in to show that they are equal, to show that they are congruent. All right, and then the next converse we're going to look at is the converse of the alternate interior angles theorem. So here it says if two coplanar lines are cut by a transversal so that a pair of alternate interior angles are congruent, then the two lines are parallel. So remember, all of these started with the same hypothesis, okay, that your lines were parallel. So it makes sense if they started with the same hypothesis, they're going to have the same conclusion, because with the converse, we're switching those. So for this one, again, angle 1 is congruent to angle 2. If that's something that is given, then we can conclude that your two lines are parallel. So M would be parallel to N by the converse. Again, you have to write out the converse of the alternate interior angles theorem. Okay, and it's fine if you abbreviate just like that. All right, let's flip it over. And then the next one we're looking at is the converse of the alternate exterior angles theorem. And I bet you can already figure out what this is going to be, right? So if you have the two lines that are cut by a transversal so that alternate exterior angles are congruent, then the lines are parallel. Do, 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 do. Yep. Okay, so again, that makes sense because all the hypotheses were the same. Now all the conclusions are going to be the same when they switch. So you were given that angle 3 was congruent to angle 4. So your conclusion is going to be that M is parallel to N by the converse of the alternate exterior angles theorem. Right? Now, when you are doing this yourself, you are going to have to analyze what type of angles you have, and then you're going to use the corresponding converse of the theorem or the postulate. For the last one, we are going to write this out. So the converse of the same side interior angles theorem tells us, and you can probably guess what the first part is going to be, if you have, if two coplanar lines, so if two coplanar lines are cut by a transversal so that a pair of same side interior angles are, and remember, these are not congruent, they are supplementary. So I'm using colors so those stand out. Then the two lines are parallel. So we are going to look at this example. So we have the measure of angle 5 and the measure of angle 6 equals 180. So if that's given to us, then our conclusion is going to be, and we're going to label these M and N, that M is parallel to N by the converse of the same side interior angles theorem. Okay, awesome. All right, you guys are doing a good job watching your video. You are almost done. So for the next one, your proof, what we have to do is draw our picture. Okay, so this picture would go with it. It's just not drawn in, so we are going to draw it in ourselves. So if you have a straight edge, you can use your straight edge. I recommend it. Makes it look nice and pretty. So for this proof, you also have a diagram. The diagrams are really important because they're going to help you figure out what types of angles you have. And we are going to be marking our diagrams. Okay, so if you have one that you are doing in your book, I definitely recommend writing that out on your paper so you can mark it up. Okay, and these are all lines. So I'm just putting my arrows to signify the lines, okay, not that they're parallel. And we're going to call the first one P, this one is R, this line is L, this one is M, and then we're going to call this angle 1, this one 2, and this one 3. All right, so we are given two statements. We have to prove that R is parallel to P. Whenever you're trying to prove something is parallel, you need to use the converse. Okay, so we'll talk about that more when we get there. But we also talked a lot about how you can fill in some boxes based on this. So remember, what you have to prove, that's always going to go in the last statement. And then with the given, we talk about how that goes in the first statement. This one we're actually going to break up into two parts. So the first one we're going to use is that L is parallel to M, and then we can use the given statement. Now once you do that, I need you to mark that off on your diagram. So if L is parallel to M, the way that we'd show that is we would draw these little arrows in. All right, and then we want to think about, okay, if L is parallel to M, that is going to mean all four of these theorems are true. Okay, if all four of these theorems are true, that means because your two parallel lines are cut by the transversal, corresponding angles are congruent, alternate interior angles are congruent, alternate exterior are congruent, and same side interior are supplementary. All right, now if you're listening to the video right now, what I want you to do is, next to this, I want you to draw a little heart. So I put a little star. I want you to draw a little heart there. Okay, and then I'll know that you were listening to your video. All right, now, in our picture, we have a few different types of angles. So eventually we're going to get to 1 is congruent to 3. Okay, when these two are parallel, we're going to focus on angle 1 and 2. So angle 1 and angle 2 are congruent because they are what type of angles? Sometimes it might be helpful for you to turn the page so that you can see what type of angles these are, or even just marking them in your diagram. These are on the same side, but they are not both inside the two lines. So if they're on the same side, the same position, they are corresponding. So this is going to be the corresponding angles postulate. Okay, so now I'm going to use that angle 1 is congruent to angle 3. That is something that is given to you. Okay, and then from there, we have to go one more to figure out if R is parallel to P. So what you want to happen is you want to find a pair of angles that are going to fit one of your converses to help you find this last statement here. So let's look at the angles that we haven't used yet. So if we look, we have 1 is congruent to 2, we have 1 is congruent to 3. If you look at these two statements, you have two angles that are congruent to 1, okay? Which means if they're congruent to the same angle, they have to be congruent to each other. So because 1 is congruent to both 2 and 3, they're congruent to each other, and that is the transitive property. So we worked on that a lot in chapter 2, okay? If you have two things congruent to the same thing, it will be your transitive property. And then why are these parallel? Well, look at the relationship between 2 and 3. So on your diagram, if 2 and 3 are congruent, let's identify what they are. Ask yourself, are they on the same side or opposite sides? Opposite. So they're either opposite exterior or opposite interior. Because they're outside P and R, they are alternate exterior. So we are going to use the converse, has to be the converse of the alternate exterior angles theorem. All right, so I said this to you once already, so we're just going to write a note as our reminder. And our note is to prove lines are parallel. And yes, you need to write this down. So to prove lines are parallel, you will use the converse. Okay, you will use the converse. Well, when do you use the other ones? Great question. To prove that angles are congruent or supplementary, because remember the same side are supplementary, that's when you will use the theorem or postulate. Okay, so to prove they're congruent, that would be corresponding alternate interior, alternate exterior. To prove they're supplementary, that would be the same side interior. Okay, you would just use those theorems. It's to prove the lines are parallel when you are going to use the converse. Okay, so you don't need to do this homework today. We'll be working on that tomorrow when you come in if you have watched your notes video. So you can write this down so you're ready to go for tomorrow. So we are going to do page 166, numbers 1 through 10, and then 24 through 29. All right, so your quiz over 3-1, 3-2, and 3-3 is going to be on Friday. So tomorrow we're going to go over your homework packet from today, and then I will give you time to work on 3.3. And then for tomorrow, you will, after you do your homework, you will check it and study for your quiz. All right, so if you have questions, email me, and there you go. Good job.